Welcome back. We will start with orthographic projection in part A of computer aided machine drawing. So before going to the orthographic projections, let us recall what we have studied in the previous class about the first angle projection. So here we have written the first angle projection. In the first angle projection, if you remember, we have the observer, then the object, and then we have the section plane. So in that, the front view will be here and it will be on the vertical plane. The top view will be below that on the horizontal plane, and the right side view will be on the left profile plane on the left side of the front view, and the left side view will be on the right profile plane on the right side of the front view. So we need to remember this, and this is the first angle of projection will be used throughout the computer aided machine drawing. So we need to remember this, and another way of identifying which is the angle of projection is with the help of this diagram, which will be given at the bottom of the drawing sheet. So at the bottom of the drawing sheet in the title box, this diagram will be given, and based on this, so as explained in the previous class, here we have a frustum of a cone. So since we here in the side view, since we are able to see both the circles, this end and this end, both the smaller end and the larger end, it is visible on the side view. So this is we are viewing the frustum of the cone from the right side, and the right side view is on the left side. So that is the notation, or that is the method of first angle of projection. So by looking at this, we should be able to identify this is the first angle projection. And in computer aided machine drawing, we will be using the first angle of projection. So whenever we are writing the orthographic projection, generally in the question paper, where it will be asked, or you will be asked to write the front view, top view and the side view. The side view can be the right side view or the left side view, and you need to arrange the diagrams. You need to first, we will start with the front view. So you need to write the front view in such a way that if the right side view is asked, then you need to leave some space on the left side of the front view, and if the left side view is asked, then you need to leave some space on the right side of the front view to draw the side view. So we call any given object or a diagram, we call a view as a front view, which gives us maximum dimensions of that diagram. Here we will start with the first problem. Here we have written the pictorial view of that problem. Here we can see that we have a rectangular prism with 3 steps on it, and each surface is labeled with letters A, B, C, D, E, F, G and H. These are the labels given for each surfaces on this diagram or on this object. Now let us look at the dimensions. So the height of this prism is 60 millimeter, and the breadth or the depth of this prism is 90 millimeter, and the width of this is 125 millimeter. So when I am looking from this orientation, I can see the maximum surfaces. I can see surface D, E, F, and I will get the maximum dimensions with that. So I will call this as the front view, and in this problem you need to write the front view, then the top view. So this becomes the surface A. When you are looking the surface A, that becomes the top view, and then you need to write the left side view. So for that, first what we have to do is we need to go through the dimensions in this diagram. So the total width is 125, height is 60 and depth is 90 mm. Then here you can see the dimensions of the step. Vertical height of the step is, each of the step is 20 millimeter in height, and the depth is, here you can see the depth, that is 30 millimeter, and the entire width is 125 millimeter. So here this section is 45 millimeter. And another way of finding out which one is the front view is, in some of the problems they will write the view as front view, or they will just give this kind of arrow. So this arrow mark represents the front view, and if it is given at the top and if it is facing downwards, then that will be your top view, and if it is given on the sides, then that will be the side view which you have to write. In most of the problems they will specify the front view, they may not specify the side or the top view, but they will give it in wordings. So based on that you need to draw the views. So now we have seen the dimensions of this problem. Let us come to the front view. First, whenever you are drawing any orthographic projections of a given object or solid, you need to start with the front view. So you need to fix the position of the front view based on this. If the right side view is asked in the problem, then you need to leave some space on the left side of the front view, and then you need to start with the front view. If the left side view is asked, then you need to leave some space on the right side of the front view, and then you need to start with the front view. Here we have written the front view, top view and the side view. First let us concentrate on front view. So in this front view, first I will write the outermost dimension, that is I will complete this rectangle which is visible from the front. When I am looking from the front, I am able to see this vertical surface D, I am able to see vertical surface F, and I am able to see vertical surface E. These are the three surfaces which are visible from the front. So first I will draw this entire rectangle with a dimension of 125 by 60. So that is the outermost dimension visible in the front view. So I will draw that. Then now I need to draw surface E and F as well as D. So for that I will refer the diagram. So here this width is given as 45. So at a distance of 45 from the left end, I will draw a vertical line. I will start with thin lines. Once I determine all the visible boundaries, then I will darken them. So I have written a thin line here. First I will write a thin line here. Then now I need to these edges. So this edge and this edge will be one behind the other. So only the front edge will be visible. Again here this two edges will be one behind the other when you are looking from the front. So only this front edge will be visible. These two will be parallel to each other, and these two will be parallel, and all these lines are parallel to each other. So now what I will do is, I will see from the top, I will try to write this edge which will coincide with this edge, and that is at a height of 20 mm from the top surface. From the top surface at a distance of 20 mm, again I will write a thin line till I meet this vertical line. Then now I need to draw this edge. For that again it is at a distance of 20 mm from this front edge. So from this I will measure 20 mm and then I will draw a line. Okay, now I have written the front view. Now I need to identify the visible edges and I need to darken them. So the exterior ends will be visible, so I will darken them, and from here till here it will be visible, so I will darken this, and from these two lines I will darken. That will complete our front view. Once you complete the front view, then you have to write the dimensions. To write the dimensions, we can use this method. We can write the line, and then we can draw two arrows at the ends, and then next to that we can write the dimension, and we can also follow this method where we have drawn a line and in between the line we have drawn the dimension. So these two methods can be used in ISO standards. Okay. Now I will write all the dimensions. Again here if you see, the total height is 60 mm. So this is 20 and this is 20. So the third portion will also be 20. So this is a redundant dimension. You can write or you can omit the writing of that dimension. Now once we have done with the front view, we need to write the top view, and you should be careful that the top view should be exactly below the front view. So for that I will draw two projection lines, and at an appropriate distance from the front view I will draw a horizontal line. Now again when I am looking from the top, the outermost boundaries will be rectangular in dimension with a width of 125 and a height of 90 millimeters. So I will draw this thin this line, I will draw a thin line, and from a distance of 90 millimeter from this line I will draw one more line. that fixes the dimension. So once that is done, then what I will do is, now I need to write the surface C and B which are visible in the top. So to draw that, now we have three surfaces A, B and C. So I have written the entire rectangle. Now I have to write B and C. So for that purpose, what I will do is, I'll look at the diagram. So this is the top for in the front view. So this portion or this line is the line which is here. So from this I can see that this edge as well as this edge, they are parallel to each other and one behind the other. So they are at a distance of 30 mm from this edge. So from the top I'll measure 30 mm and I'll draw a thin line. Okay, then again if I look at the these two, they are at a distance of, these two edges, they are at a distance of 30 mm from this two edges. So from here I will draw one more line which is at a distance of 30 mm. And to locate this line, I don't have to measure 45 mm here again. I have that same line in the front view. From the front view I will draw a projection line. So this is the projection line I have taken, and then I will join that line. So now I know this is the surface A, now this is surface B and this is surface C. So I will darken all the visible edges. So here I have this outermost rectangle is visible, so I will darken that, and then from here to here I have a visible edge, I will darken that, and from here to here I have a visible edge. So from here till here I will darken it. Here we don't have any edge, it is a projection line, and then we have one more edge from here to here, that is also visible, so I will darken that. This completes the construction of top view. Once it is done, again you have to write the dimensions. Now since we have shown this dimension in the front view itself, we don't have to show it again here. And since this total height is 90, this height is 30 and this height is 30, again you don't have to show this height because that becomes a redundant dimension. Now we will go to the side view. When I am looking from this side, I am able to see this surface G and this entire surface H. So now before drawing that, first when I look at this object from the side, again it will appear as a rectangle of height 60 mm and width which is 90 mm, and always the side view should be in alignment with the front view. So for that I will draw projection lines from the extreme ends of the front view. After that, at a convenient distance, I will draw a vertical line. Okay, this line corresponds to this edge. Okay, I am seeing from this side. So whatever the line we have written here corresponds to this line. So once I write that line, then I will measure 90 mm because that is the width in the side view. I will measure 90 mm and I will draw one more vertical line. That fixes the outer boundaries. Now I need to write these steps. From here we have 3 steps that should be written in the side view. So for that, the first vertical line is at a distance of 30 mm from this edge. So from here I will measure 30 mm and then I will draw a thin vertical line. Remember, first when you are constructing, the lines should be thin lines. Once the construction is over, then you need to identify the visible edges and you need to darken them. Okay. From this vertical line I have a horizontal line and that is for a distance of 30 mm. So to locate this point, again I know from a height it is at a height of 20 mm. So I can measure 20 mm from here and draw mark this point, or I can project whatever we have written in the front view. So we have written a projection line here, and from where this vertical line meets the projection line, I will stop the vertical line there, and from here again I will measure 30 mm and I will draw the horizontal line. This is the horizontal line. After that again I have one vertical line and that height is for 20 mm. So instead of measuring 20 mm again here, I have projected a line from here. So I will stop the vertical line. at this projection line. After that, I need to draw a 30 mm line, horizontal line. So for that, I will continue on this projection line till I meet this end. That completes the construction. Now I need to thicken all the visible edges. So the outermost rectangle is visible, I will thicken it, and from here we can see that we have visible edges in this shape and this shape of steps. So from here I will darken all these steps. That completes the construction. Again, after completing the construction, you need to write the dimensions. Again, we have shown the dimension here. So this same dimension can be shown here. That completes the construction of the side view. Once you complete the construction of front, top and side view and you have written the dimensions, below the views you need to name the view. So just below the front view I will write it as front view, just below the top view I will write it as top view, and just below the side view I have written the side view. This is the right side view which is on the left side. If you have written the side view on the right side, then it becomes the left side view. So that depends on the side view asked. So that should be specified as per the standards. Any questions?
Sir, should we write 1:1 scale drawing or rough sketch?
Here in orthographic projection, you have to write it for 1:1 scale. If the dimension of the A4 sheet is not sufficient to draw the picture, front, top as well as side view in 1:1 scale, then you can reduce it. Otherwise, you have to always write the orthographic projections in 1:1 scale. Next.
So for this problem, if they ask left side view,
here the object will be given in isometric view, and in isometric view any three orientations will be visible. So here in this diagram, if I consider this as the front view, the front side is visible, the top side is visible and the right side is visible. The back side and the left side are not visible, as well as the bottom side. These three views are not visible because the object will be in between the observer and the projection planes. So because of that, this diagram, generally they will not ask for the left side view. If they ask for the left side view, since the dimensions are not visible in the left side view or the features are not visible in the left side view, so what you have to do is you have to write the same on the right side, and these edges becomes invisible, so you have to show them with dotted lines.
So is that arrow mark is compulsory for all the 3D views?
Yeah, this arrow mark, at least the front view will be specified with the help of arrow mark or with the help of text such as front view or FV. For the right side view or RV, and for the top view there will be arrow mark or it will be written as top view or TV. So these are the notations generally used to represent the views. So if this is on the left side, then if the left side features are visible, then we call it as left side view. Or in the same diagram, if this becomes the front view for the observer, if this is given as the front view, then this becomes the left side view and this will remain as the top view. Again, it depends on the orientation of the object and the position of the observer.
Sir, in the questions, will they specify front view?
Yeah, in the questions they have to specify the front view, otherwise you can choose according to your convenience the front view of the object. Now let us see the construction of the first problem in our sketchbook. It is advised to keep the sketchbook in the landscape mode or the horizontal manner, and depending on whether the right side view is asked or the left side view is asked, you need to locate the position of the front view. In this problem, the right side view is asked, so the right side view will be on the left side of the front view. For that reason, what I'll do is I'll write the front view in the right top corner of the sketchbook. So I'll start with the front view. I'll leave 1 centimeter from the top and 1 centimeter from the side. Then I'll start with the construction. So while constructing, first we need to start with thin lines. As we know, in this problem, the front view appears to be a rectangle of 60 mm in height and 125 mm in length. I'll start with the construction line, so I'll use thin lines. So I'll draw a line for 6 centimeter or 60 millimeter, then 12.5 centimeter or 125 millimeters. I'll complete this rectangle. Here, another thing which you need to remember is this sketchbook, the divisions on this, 1 unit is equal to 10 millimeter, which means to say that from here till here, that is 1 division, and that is equal to 10 millimeter. So if I take a square in this grid, then that will be 10 by 10 millimeter square. So you don't have to really use scale to measure the dimension, that is if it is 60, 65 or any other values. If it is 61 millimeter or 62 millimeter, then you may have to use scale. If it is 60 millimeter or 65, 100 millimeter or 125 millimeter, you don't have to use scale, you can just count it. But for drawing these lines, we need scale. Now I'll complete this. Once I complete the outermost rectangle, now I need to show the surfaces D, E and F. And I know that surface E and F has a vertical edge which is at a distance of 45 millimeter end. So from this end I will measure 45 millimeter, or I can just count the blocks. One, this is half of 5 millimeter or half a centimeter, then 1, 2, 3, 4. So here we have a vertical line or a visible edge. So I'll just draw a thin line here. Okay, now I know that surface E is at the top here and it has a height of 20 millimeters. So I'll measure 2 blocks and then I'll draw a horizontal line here. And surface F is here, and that is at a height of 20 millimeter from surface E. So here I'll count 2 blocks and then I'll draw one more horizontal line. Here I am purposely expanding the line so that I can use the same construction line for the side view. Now I have completed the construction of the front view. Now I need to highlight or darken all the visible edges. So I'll start with the outermost rectangle. Always outermost boundaries are visible. So I'll darken them first. Now I need to show surface E and F. I know that here I have surface E and here I have surface F, and the vertical edge is at a distance of 45 millimeter from here. I had written a projection line, and I know that the visible edge here is for a distance of 40 mm from the top. So I'll draw a thick line here, and then here this is the end of surface F. So I'll draw one more thick line here, and here I have the edge between surface E and F. So I'll thicken that. Now we have completed the construction in the front view. Now we need to show the dimensions. So to show the dimensions, what I'll do is I'll draw thin lines on the extreme ends of the lines where we need to show the dimension, and this thin line should not touch the actual figure, and then I'll join those two at the center with another thin line. Once I have constructed this, I need to draw an arrowhead at the end. So this arrowhead should be of ratio 1:3. So if I draw 1 millimeter in the vertical direction, then the horizontal distance should be 3. After drawing this, I'll write the dimension below that. Here the total length is 125 millimeter. Again, I'm not writing the unit here millimeter because that is already given in this sketch. Go. Now this distance is 45 millimeter. And here these are 20 millimeters. The overall height is 60 millimeter. I'll show that here. Although this will also be 20, that will be a redundant dimension, so I don't have to show that. Now we have completed the front view. So below this, I'll write front view. Now let us construct the top view. What I'll do is, I'll draw projection lines from the front view wherever we have edges. So wherever we have vertical edges, there I'll draw the projection lines here. And I'll leave approximately 1 or 2 centimeters below the front view, and then I'll draw a horizontal line here. From here, our top view starts, and we know that in this problem, the top view appears to be a rectangle of 90 millimeter by 125 millimeter. From here to here, it is 125 millimeter. Now I need to measure 90 millimeter from the top, or I can count 9 boxes here, or 9 grids. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that corresponds to 90 millimeter. So here I'll draw a horizontal line. Now this completes the outer rectangle. Now we need to show surface A, B and C. Surface A is here, surface B is here and surface C is here. And to locate that, we know that the top of the surface B is at a distance of 30 millimeter from this line. So when you are looking from the top, surface B will be somewhere here and surface C will be somewhere here, and surface B is at a distance of 30 millimeter from this line. So I'll measure 30 millimeter, 1, 2, 3. So I'll count 3 boxes, and there I'll draw a horizontal line. I'll draw this horizontal line till it meets this projection line, because at that point or at that location the surface B ends. So I have drawn a line. So now from here, this entire surface is surface A. Now we have separated surface A from B and C. Now I need to separate B and C. And I know that the width of surface B or the height of surface B is also 30 millimeter. So I'll count 3 grid lines, and then I'll draw another horizontal line here. So now I have created surface A, B and C here. Now I need to thicken all the visible edges. So I know that the outermost rectangle will be visible. So first I'll thicken it. Now I know that there is a visible edge here, here as well as from here till here. So I'll thicken all those visible edges. Now we have drawn all the visible edges. I'll label the surfaces. This is A, this is B and this is C. This is just for your reference. You don't have to label them every time. Now we need to show the dimensions. So the total height in the top view is 90 millimeter. This is 90 millimeter. And from here till here it is 30 millimeter. As well as the height of surface B is also 30 millimeter in the top view. This is also 30. And this will also be 30, but since we know that the total height is 90 and these two are 30, 30, so we don't have to show that. And this width, the length is shown in the front view itself, so we don't have to show it again. So this is our top view. Now we will construct the side view. What I'll do is I'll extend all the horizontal lines in the front view towards the left of the front view. we are constructing the right side view. Since we are using the convention of first angle projection, the right side view will be on the left side of the front view. So you need to remember this. I'll extend all the horizontal lines in the front view towards the left of the front view. Once we are done with this, I'll leave 1 or 2 centimeters to the left of the front view and I'll start with the construction. You need to plan it here because in the side view it appears to be of a rectangle of 90 mm by 60 mm height. So here we have 60 mm. So I'll just see where I'll get 90 mm. So here from the edge of the sheet till here it is 90 mm. So I'll start here. I'll draw a vertical line here and I'll draw one more vertical line here because I know this distance is 90 mm. Now we need to show surface G and H. Surface G is somewhere here and H is somewhere here, and we have steps, and the width of each step is 90 and the height of the width of each step is 30 mm and the height is 90 and the height is 20 mm. So from here 1, 2, 3, I need to come down till I reach this projection line. So I'll draw a thin line, then I'll measure again 3 boxes, 1, 2, 3. Here I'll draw one more construction line and we need to move horizontally by 3 boxes, so that comes to the end of the diagram. So now we have drawn the side view. Now I will highlight all the visible edges. So from here till here it is visible. All the outermost edges are visible. First I will draw all the outermost edges. Now we have a step here, which is we have edges which are visible here in the form of steps. So I'll connect them. We have a horizontal line here. We have a vertical edge here. We have another horizontal edge here. Now we have completed the construction of side view. This is our surface G and this is our surface H. Again, this need not be shown in all the orthographic projection problems. Here we are showing it so that it will be easy for you to understand what we are doing over this sheet. Now I need to show the dimensions. The height as well as the height of these vertical edges are already shown here, so we don't have to show that again. Now we need to show the dimensions for the horizontal edges. I know that these two have a length of 30 mm. This is 30 mm. This is also 30 mm. And this entire length is 90 mm. This completes the construction. Now I will write this as the right side view. This completes the solution for the first problem in your sketchbook.